let's look at an example of free body diagrams and let's walk step by step on how to draw them and how to solve these types of problems. So in this problem, we have a motor draws in the cable at a rate of V equals 0.05 t squared meters per second, where t is in seconds. Determine the tension developed in the cable when t equals 5 seconds. The crate has a mass of 20 kilograms and the coefficient of kinetic friction between the crate and the ground is mu equals 0.2. So right away, let's start by drawing our free body diagram. So here's our crate, and let's now just start to think about what forces we have on this object. So maybe the most obvious is going to be our weight. And we know weight equals mass times gravity. So we're going to say 20 times 9.81, and that's going to give us an answer in newtons. So we're going to say over here, we're going to have 20 times 9.81. That's going to be our weight. We know too that it's being pulled by this cable, and that's going to give us a tension, and we're also going to be solving for this T. And they give us our coefficient of friction, but we know also that there's just going to be a friction force. And as we always have, we have a normal force whenever we have an object that's resting on a ground or a surface weighing down on that. We're going to have our normal force, which is going to be, working opposite against our weight. So there is our free body diagram. Really quickly, I just want to show the kinetic diagram. I realized as I was editing that I didn't show this as part of the problem. You're mostly going to be relying on your free body diagrams, but just so you know, this is the kinetic diagram, and you can see we have our F on our left side with our free body diagram and the MA on our right. So F equals MA, so you could say, these two really represent the full equation of motion. Okay, back to the problem. So using some of these equations that we know, some of the forces in the y are going to equal mass times acceleration in the y. So what are our forces in the y direction? So we have our normal force minus our weight. And that'll equal our mass times our acceleration in the y. And our acceleration in the y is just going to be 0. So actually, we can use this to solve. So we can say our normal force is going to be equal to 196.2 newtons. So now let's try our sum of the forces in the x is going to be equal to mass times acceleration in the x. And so what are our forces in the x? So we have our positive tension force, and we're going to subtract our friction force equals our mass times our acceleration. So we're going to say 20 times AX. So we're going to have to solve for our acceleration in the x as well as our friction. So our equation for friction, I think everybody remembers it this way, just spells out fun. Oops. So that's a really easy way to remember. And let's solve for friction. So friction, we're going to say force of friction equals 0.2, which is given to us up here, times our normal force, which is 196.2. So that will give us a friction force of 39.24. And we're also going to need to look for the acceleration in the x. So we know our v, so we know that a A equals dv dt. And v is given to us. So let's take the derivative of v with respect to time. And that'll give us 0.05 times 2t. So A equals 0.05 2t. And then we're going to plug in 5 seconds. So acceleration is going to be equal to 0.5 meters per second squared. So now we can plug that in over here. So we'll say our tension minus 39.24 equals 20 times 0.5. And that'll give us a tension value of 49.2 newtons. And that's our final answer. Thank you for watching. If you like this video, please be sure to give it a thumbs up and subscribe. That really helps support my channel and helps me continue making videos for you guys. I'll see you next time.